This is the Math 2 lesson summary video for the lesson entitled Perfecting My Quads. The purpose of this lesson is to practice solving a quadratic equation using all of the different methods that we have learned so far in this unit, such as factoring, quadratic formula, completing the square to isolate the x value, or just using algebraic reasoning. In the introduction to this lesson, we are told that several friends are discussing their favorite methods to solving a quadratic equation, and they are all different. Carlos prefers to use a table. Zach prefers to use a graph. Clarita prefers to factor. Tia wants to solve by completing the square, and Tehani uses the quadratic formula. In this task, we are practicing our skills on solving a quadratic equation using all of these different methods. To demonstrate how we might solve a quadratic function using all of these methods, let's examine the first function of the lesson, which is x squared minus 2x minus 15 equals 0. Carlos says he loves to examine a table of values to solve. If we place this in our calculator and we look at our table of values, we do notice that when we cross the x-axis, our y values should always be 0. If we look at this table, we can see that negative 3, 0 and 5, 0 are solutions as the y values are 0. Moving along to Zach's strategy is to look at the graph of the function. If we look at the graph, we are trying to find where the parabola crosses the x-axis. We can see that it intersects the x-axis at x equals negative 3 and at x equals 5. Another way to check would be to use our calc function on the calculator. To do that, we would go to our graphing calculator, type in the function in our y equals, second, trace function, which is calc, and when we're trying to find the x-intercepts, we can go to number 2, which zeros is another term which we learned in the last section for trying to find the x-intercepts. If we click the zeros, we are asked left bound. We will need to move our cursor to the left of the x-axis. Press enter. We'll then move it to the right. It'll say right bound of the x-axis. Press enter. It'll say guess, and we press enter again. Therefore, we can see that using this strategy, negative 3, 0 is indeed an x-intercept. We can also do the same thing on the right side. Moving along to Clarita's strategy, she prefers to factor. If we factor the function x squared minus 2x minus 15, recall from our previous lessons that we need two numbers that multiply to c and add to b. Those two values will be negative 5 and positive 3. Therefore, our factors will be x minus 5 and x plus 3. Recall that when we're crossing the x-axis, y is always 0, and so we will set each of our factors equal to 0, and we will solve for x. Therefore, our factors, or our x-intercepts, are x equals 5 and x equals negative 3. Tia's strategy is to solve by completing the square. In our previous unit, we focused on how to complete the square to find the vertex. Remember that we will take half of b and square it. Half of negative 2 squared would be plus 1. And then we write this as a quantity squared. So this would be x minus 1 squared. And we need to go from one little square to negative 15. So mathematically, to go from a positive 1 to negative 15, we would need to subtract 16. Now, Tia's strategy is to solve. That means we need to get x by itself. In order to solve, we'll add 16 to both sides. We'll get the quantity x minus 1 squared equals positive 16. To cancel out a square, we will need to take the square root of both sides. We'll be left with just x minus 1 on the left, and whenever we take the square root of both sides, we have two answers, plus and minus. The square root of 16 will be plus and minus 4. Therefore, our solutions should be x equals 4 plus 1, which is 5, and x equals negative 4 plus 1, which is negative 3. And those indeed check based on what we did with the other methods. Finally, Tehani loves to use the quadratic formula to solve. So we're going to use our formula that we learned in our previous lessons in order to solve this using Tehani's method. Recall that the formula for the quadratic function is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Our a value in this case was 1, our b value is negative 2, and our c value is negative 15. We are going to substitute in wherever we see a, b, and c. So negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 15 divided by 2 times 1. When we simplify that, negative 1 times negative 2 is a positive 2, plus or minus negative 2 squared is 4, and negative 4 times 1 times negative 15 is 60, divided by 2. If we simplify what's under the square root, we will get the square root of 64, which is a nice whole number square. So we will get 2 plus or minus 8 divided by 2. So we have two answers here again, x equals 2 plus 8 divided by 2, and x equals 2 minus 8 divided by 2. Therefore, our solutions are 10 divided by 2, which is 5, and 2 minus 8 divided by 2, which is negative 3. We can see that all of these methods produce the same answers to our quadratic function. So if we are asked to solve, we have many methods in order to choose from. As we progress through this lesson, we did notice that factoring and using a table of values will not always work to help us solve. In those cases, we will have to either use the quadratic formula, graphing, or completing the square to solve to find the exact x-intercepts. We then move to the last question. We are provided with an extra challenge and asked how we might think each student would have solved the following equations. y1 was x squared minus 4x plus 1, which we can see is indeed a parabola, and y2 was x minus 3. If we're asked to solve this system, we know that one is a parabola and one is a line. So the solutions to the parabola and the line will be where the two intersect. So it was our goal to figure out how algebraically we could find those solutions. We'll first focus on Carlos's strategy, which is to use a table of values. Carlos would be looking to see where the x matches with the same y value. If we look right here, when x is 1, we see that y is negative 2 for both of those values. Now what I did here to find this table is I actually plotted these two functions in my y equals on my calculator. To show you how to do that, I'll go back to my y equals and I'll type in both of my new functions, x squared minus 4x plus 1, and my second function, my linear function, was x minus 3. To find where these two intersect, we'll go second graph, which will give us a table. And so I found the table from the previous screen by looking to see which x value had the same y value. So I see that 1, negative 2 is an intersection point, and I also see that at x is 4, y has the same value, so 4, 1. The nice thing about this screen is I can also move to Zach's strategy, which is to look at a graph. And I can see right here and right here that the line that's in red and the parabola that's in blue do intersect at those 2 points. If I go back to my previous screen, you can see Zach's strategy right here graphed. And we do indeed see that 4, 1 again, and the point 1, negative 2 are indeed the intersection points of the parabola and the line. So let's move now to Clarita's strategy. Clarita loves to factor, if you recall. So in order to factor, what we're going to do is we want to set the equations equal to each other. And then we're going to combine like terms and get 0 on one side. Remember, when you cross the x-axis, y is always 0. Therefore, if we combine like terms, we should get a quadratic function x squared minus 5x plus 4 equals 0. We're going to solve this like we've done in our previous lessons. We'll try and factor first, find two numbers that multiply to 4 and add to -5, and those two numbers will be -4 and -1. When we set our factors equal to 0, we get x is 4 and x is 1. However, in this case, we are not just finding our x values because we're trying to find where the parabola and the line intersect. So we're going a step further. We have to plug the 4 in to one of our original functions. So I'm going to take y2 and I'm going to plug the 4 in. 4 minus 3 is 1. We can see that above. And then our other x value was 1. 1 minus 3 is -2. And we see that point here. Moving to Tia's strategy is to complete the square. So we're going to set our functions again equal to each other. We're going to combine like terms to get 0 on one side. Recall that we always take half of b and square it. So we're going to take half of -5 and square it. When we do that, we're going to get our quantity squared as x minus 5 halves squared. And recall that you need to go from 4 little squares. So we should get -9/4 when we're completing the square. When we're asked to solve, we're going to add 9/4 to the other side and take the square root. Remember, when you take the square root of both sides, you have a plus and minus answer. And you're going to add 5 halves to get 5 halves plus 3 halves and 5 halves minus 3 halves. Moving back to my calculator, 5 halves plus 3 halves is 4, and 5 halves minus 3 halves is 1. I will then also plug those values back in to get my final solutions of 4, 1, and 1, -2. And the last strategy is Tehani's, which is using the quadratic formula. Once we got our function in the standard form, x squared minus 5x plus 4 equals 0, we'll plug a in as a 1, b in as -5, and c as +4. When we plug into the quadratic formula, we will also get 4 and 1, so our solutions will be the same, 4, 1, and 1, -2. In summary, we have practiced our skills in solving a quadratic function in various ways. Some of these methods, like factoring, a table of values, and a graph, won't always be the most helpful in solving. In these cases, we would need to use the quadratic formula or completing the square to isolate the x value. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.